sometimes when searching the web and coming back to some of the docs that are on Interlisp, and I've seen links on here that are broken also. It seems like some of them have gotten fixed. But it looks like the docs have changed to documentation instead of docs, if I could spell correctly. And then on some of these, they're just not there anymore. They've been renamed maybe. Or in this case, this book's not there, but the third book is there. So the easiest way to get around is just when you're on their website, like right here where you come up to this, just click on documentation. And if you're somewhere else on the page, I guess you can come over here and find documentation and click there. It's the same page. And then right here, you'll find these books, and these links actually work. I think that one I changed, though, was that a 1? Oh, that was 2. That was a 1986 book, so I guess they're all there, 1, 2, and this IRM. I think that's the only ones that were over there. 1, there's 2, there's 3, and IRM. So maybe this is the first one. I don't know if it just changed the name or if that's a different book. Anyway, what I was trying to make a video about is, I think I was trying to look for debugging, and I came across this, and it's on the DTIC military site. And it looks like at one point they were trying to implement Interlisp on the VAX, and I want to say it's like Defense Technology Information Center or something like that. We can see it's like an unclassified document, so I guess it's cool to look at it. And over here it starts talking about like them implementing this, but it's talking about like right here they're talking about implementing Interlisp on the VAX, but they hadn't chose this specifically. They haven't chose what Lisp or what system they were going to use at this particular time, and they want to be. I want to say they were trying to be like 100% compatible with Interlisp 10, which I think is named because it's off the DEC, the PDB 10. And right here, yeah, PDB 10 under 10X, the TOPS 20 operating system. And Interlisp D being developed at Palo Alto Research Center, Park. And they were trying to like also I want to say they were trying to use some like the multi-list stuff. And it's talking about like so it goes with like the virtual machine that's running underneath it and stuff like that. It's kind of interesting. And so here's like the history of the part, and I guess they're saying like the research community ceased to start considering Interlisp useful enough for like the stuff they were trying to do because it was limited in address space. I guess that's being on the PDB-10, I guess. And so they're trying to figure out what to use, and they were talking about just abandoning Interlisp altogether in favor of MacLisp or Lisp Machine Nil Common Lisp. And then also keeping in mind whatever Lisp dialect they chose is going to influence what machine they can run it on top of. And so they were talking about using like the Catter, MIT, Lisp Machine, or Xerox 1100. And then the Interlisp machines ran on like Dolphins, Delrado, or something like that. And another one, I think there was 3Ds. And so here they're trying to choose which one. They're looking at Perk and Prime. And also, I want to say that one's a Motorola machine. They ended up choosing the VAX, which is also DEC. And then I guess they started working seriously on this in 1980 and had chosen C. And then by 1982, they had like something, the first release was released publicly, I guess. So they were probably using it internally before that. So here it's like talking about whatever dialect of Lisp they use is going to, determine quite a bit of different stuff. And they wanted most of the stuff to be in Lisp, but like a small part of the kernel might still have to be in something else, especially depending on, if they chose a Lisp machine, that's not going to be too bad, but it's almost going to be impossible to run it on Lisp at the time, I guess, totally on, whatever machines that are using. And then different types of coding was going to matter, microcode and stuff like that. And then the languages, like, because a lot of Lisp implementations will be written inside themselves, and so they're trying to consider if that could be possible here, but they rejected it because they figured basically that it would be stuck to that system if they did all the low level code in Lisp. It says that somewhere in here, and so there were a couple of languages they were considering at the time. I guess just like four of them: C, Pascal, Bliss, and assembly language. Of course, if they did an assembly language, you're tied to that machine, and one of their goals was for it to be fast. One of their goals was for it to be portable, and so assembly language is kind of out pretty fast. Bliss was one that I want to say they were thinking it would be really good, but this is like not on non-DEC systems. So although VAX and the PDP-10 that they were using for a lot of this Interlisp stuff is DEC, they didn't want to be tied to DEC all the way, and so then that left just these two. And then, of course, a lot of people like Pascal, especially people who were raised on that, love that language a lot. Wirt did this, and Nicholas Wirth, and he also did Oberon and Algol W. He did a bunch of stuff. Oberon's interesting because it was influenced by Cedar, and that came from Park. And then Acme, the editor for Plan 9, which I guess 9 Front's the most popular port that I know of at the top, like currently. There's 2 forks of that too right now, I think, too, though. And so they were, considering this pretty highly, and then they ended up using C throughout this. And so, like I want to say Interlisp 10 was like written in assembly language, but like the cost of time of doing this stuff is just way out there. I want to say they use like BCPL on some of this stuff too, maybe. And so that's why they ended up like choosing C. One, because it's portable and it's faster. It's faster. And here's where they're saying like it would have been a good choice, but not on a non-DEC machine. Then they'd have to redo everything if they're going to move their Interlisp to some other machine in the future. And so these two are the ones that they were like saying were suitable. And then Unix was chosen. Well, Unix was running on the VAX. So at that point, when they chose to use the VAX system instead of those other ones, then C was like the clear favorite. And it talks about some of the advantages of Pascal. And then I guess because maybe like Multilisp might have been running with Pascal or something, it looks like. And so they would have had everything in the Multilisp program or whatever if they ended up choosing Pascal, but ultimately they go with C. And then I guess right here, like trying to decide what should be what, like how much of it should be C or whatever versus Lisp code, because and so right here, like the ratio of C versus Interlisp on the VAX, I guess, is similar to like Interlisp 10 on the 10X. I want to say it was using BCPL, yeah, and microcode. It looks like. And then they go on talking about more top 20 stuff. Covered that enough. And so then, in addition to like low level stuff, the Interlisp VAX kernel has to have like whatever, like memory management, spaghetti stack, a garbage collector, and an interpreter. And so they went ahead and want to implement arrays and hashes and data types and all this stuff. So even like back then, Lisp had more than just like lists. And then I want to say this read and print operations. They wanted to have all that stuff inside the C implementation, I want to say. And so they divided like some of the stuff up with Lisp and C. Oh, here's where I was talking about that. Second, the C kernel contained a throwaway simple version of Lisp read eval print. So the C kernel itself had a little throwaway of just a read and print, not the eval and loop, I guess. Oh, that's for debugging purposes. That's probably how I found this document to begin with, is that them talking about that stuff. Yeah, it just goes on talking about like different stuff, like interlisp, like conversational Lisp and their records package, which I think is tied to the file package in some ways, maybe. And so they use like cross compilers. And I still think that they put like some multi-list stuff inside there from the VM specification without support of the cross compiler. I don't know. I just found this a minute ago and kind of skimmed over it. So they were like talking about using the read eval print working together with C, so they could do like debugging. So the VM could debug itself, I guess. And then like at the time the current VAX kernel is like 1,000 lines of assembly, and then 11,000 lines of C code for the management spaghetti stack. Spaghetti stack's kind of like you have a node here, and then down here you have another node, and then down here you have another node or whatever, and these things branch off like that. But the parent doesn't really know about the children. The children know about the parent, so the children can go to the parent, but not vice versa, I want to say. And also I want to say in Interlisp, I don't know about here, that the spaghetti stack, it's not a first class object, but it's almost a first class object in the medley system that we're running right now in the online thing. And it talks about the garbage collector, and so then 83,000 lines are Interlisp code itself. And 16,000 of those Interlisp lines were explicitly for this implementation. And then some other like 9,500 are shared with Interlisp D. And then quite a bit are just shared with other Interlisp implementations. I think the main goal of this was to be, they have to be 100% Interlisp 10, because a lot of the programs that people were running were dependent on that. And of course, they want to be compatible with Interlisp D also, but I don't know if it was 100% at the moment. And so it goes around talking about some of the like memory management type stuff and the pointer and all that kind of stuff. I don't know. It's interesting to read some of this stuff, and then how they were now have to mess with the garbage collection. And I think they went ahead and chose this guy's algorithm for that. Let's see what else is in here. It was, oh, I guess I started talking about shallow binding and deep binding also somewhere in here. And how much for the garbage collection, do you want to do the garbage collection? I think that's what this section is kind of talking about, is like when you like first it's like a 6 megabytes or 11 megabytes. They were trying to not do any garbage collection until it was absolutely necessary, so it wouldn't slow stuff down, I guess. Don't do it until you have to, pretty much, I guess. And then the stack representation, like the stuff they had to go through right here, and then like a call. So now it's like 10 to 15% of the time of function application and stack management code. So 10 to 15% of the time when they're running this is having to do with stack manipulation, basically. And they want to like improve that for efficiency. And then right here, Interlisp 10, I want to say was using shallow binding, yeah. And the difference between the way that shallow binding and deep binding work, it kind of goes into a little bit explanation of that. And then I want to say like shallow binding is quick to just rebind stuff, but deep binding takes longer doing this. But then once you want to start unbinding stuff, then deep binding is faster or something like that. And so in the end, these guys chose deep binding over shallow binding, where Interlisp 10 has a shallow binding. And right here it kind of explains like the look up the trade-off and stuff like that between doing the two different ones. But then at the end it says that they start questioning their choice. And so they should have, looked deeper into the performance optimizations for deep binding from the very, very start. Like, I guess it's something they started thinking of later or something. And they say that they possibly should have chose shallow binding in the end, but they didn't. And so then integer representation mattered with a 32-bit address space. And so 2 to the 31 versus 2 to 32. And then they went ahead and chose to lose the 1 bit because it's a lot of real fast. And they're saying in Interlisp applications don't typically do a lot of arithmetic. And so that's why they chose that, just so that arithmetic would be fast. Then for all other objects, they chose to have everything ordered by 2 parameters. And that was for everything else. And then this just talking about like sequence descriptors for like strings and different stuff like that. So the nth of a list will be like the same time for the nth of an array and such stuff like that. And so they finally got their Interlisp compatible and running on the system, and now it's available or whatever at the time. And then I don't know, this is going over some other languages and stuff that to do like AI type stuff and knowledge-based expert systems, because I mean that's what they were like trying to do at the time that a lot of this stuff was done. And they had their stuff to be like 1/3 as fast as the DEC KL way of doing things, and they're trying to like get their goal to was to be one half the speed of that. Then we go over some of the difficulties of implementing Interlisp. So it's saying like trying to implement Interlisp is a lot harder than just trying to, just pick like do any kind of other Lisp, because there's a whole environment that's I want to say there's a whole environment tied inside Interlisp. Kind of like Cedar would be the same way if you're trying to mess with this stuff on like Mesa and stuff. The environment and the language and all this stuff is all tied together a lot. So you can't really drop the Interlisp environment, the graphical environment, let's say, and the way everything's being done and all the stuff, advice and DWIM and all the things that are inside their conversational Lisp, and it still be actually some Interlisp. At this point, you're not really running an Interlisp, I guess. That's kind of like what this stuff went over. And then also another thing was the VM specification for Interlisp virtual machine was only 126 pages. So there's a lot of stuff that's like when you read that specification, it's like, oh yeah, Interlisp would be really easy to make, but it's not, because there's so much stuff that's not documented. I guess that you're going to run into a lot of different stuff, and it wasn't in the specification or in the manual, so it wasn't really obvious, what all you had to put inside there. So a lot of bugs are going to pop up whenever that happens. Right here, yeah, debugging. Planning, implementing, debugging becomes way more difficult because all that stuff wasn't necessarily in there. Then I want to say this ties back to the deep versus shallow binding. So because they chose deep versus shallow, some of the stuff had been changed around. And so right here you have a shallow bind. And then like the first part's kind of similar, but then when you hit this prog in right here, like this has to be changed to this. And then you can return the prog in thing right here, I guess. So some of the code has to be changed because they chose the deep binding. And then I guess this is just talking about like syscalls for the 10x system. And then this one right here, they say became like almost the Achilles heel of the implementation. Was like, I guess maybe the way they chose to do the integers, I guess. So like in other Lisp, maybe at the time, if you took the car of a number, it generates a machine check. And I guess like you're not really aware of it. So if you do something like this and it checks the car of X, and X isn't guaranteed to be a list, let's say, then a lot of these other lists or on the other implementations, if you try to take a car of a code of a number or something that's not a list, I guess it just ignored it. Maybe it didn't give an error, and so it just doesn't, doesn't mean anything. But I think the way they implemented it, it does mean something. And so that kind of like ran into some difficulty. So yeah. So in the end, their stuff is compatible with Interlist 10 and Interlist D. But Interlist D at the time was still evolving, so more work's going to have to be put into their system because Interlist D is evolving, where Interlist 10 stable, and they're not expecting anything to change. So there was still some like stuff that had to be done, and then they're trying to increase the speed of stuff. Uh, and then I guess there were some like impacts of like strings. Well, like Adam has, I don't know really because I'm more familiar with Common Lisp than any of these old Lisps. I found Interlisp because I was looking for old Lisp, and now I need to find older Lisp because I don't know like when stuff was implemented or not. Because Interlisp implemented quite a bit of stuff. Well, I'm not going to say they invented the stuff, but they might have. But at the same time, they did a lot of work pioneering to get all the stuff running on these systems and having a graphical interface and stuff. So like they did a lot of work in debugging, backtrace, and all kinds of stuff. Actually, uh, was I guess advanced. Interlist advanced a lot of this stuff. Redo and fix and advice and stuff like that was some of that stuff might have been before, like even in BBN Lisp, but Interlisp took it to a whole nother language. So in the end, it became a success. And then I guess we're just talking about now, like thinking stuff and the references. Anyway, I don't know. I just thought someone else might be interested in reading that type of stuff, or at least knowing about that document. Well, another thing about this too is nowadays, especially in Common Lisp ecosystem, you can run around all over the place and find, there's all kinds of packages. Some of those packages are going to be documented, and some of them are documented really well. Some of them aren't documented at all, and then others just use doc strings. So someone will like, there's all kinds of game engines out there that don't even have any documentation, not even documentation strings or anything. And then some of them do, and then when you go read the documentation, all of this is just like the output of a doc string basically. And back then, like back around in this time, you have like right here, you have like this is a file from a government agency, and you have like DARPA and all kinds of other people were using Lisp, and have papers that are hundreds of pages long describing their packages and stuff like that. So sometimes it's just interesting to see the difference of the way some of the stuff is now, on especially in Common Lisp, versus back in the old days when people were actually writing. I mean, the documents well written, and a lot of the documentation is really well written because it's they have like technical writers and these government institutes that are writing about the packages they made for their stuff or whatever. Ribbit.